Okay. Um, my name is Marcus Freitag, and I'm from the King George area. So.
I'm Savannah. I'm from Parkersburg.
My name is Sophia Park, and I'm from Warsaw, Virginia.
I'm not going to use the mic. I'm going to use my speaker voice. I'm Cade, and I'm from Goochland.
Can you go back for a second so you can explain our name?
Oh yeah, we are Team Potential.
Or TP.
Because we have tons of potential.
So there you go. So our objective was to make the water vehicle, the boat, this thing, that could go around the buoy and return back to the shore. So that's the buoy.
So originally when we started to think of the idea for making the boat, we decided that there are two main things that we wanted the boat to be. Lightweight, and when we were looking at the designs of some boats in the past, we noticed that some were narrow, so we decided our boat would be a little bit wider. And also, we tried not to have as much external support such as duct tape and zip ties, but that plan didn't really go out very well.
The boat kept breaking, so we had to fix it.
So when we started to actually make the boat, well, before we actually made the boat, we had to think about it in theory a little bit more. So we estimated some measurements that we thought the boat might have, and then made our calculations based off of that. We learned that we had to calculate buoyancy in order to find the potential amount of mass that it would be able to carry. So based on that, then we started to make the actual.
This is before we added this great attachment here.
So with our construction, all it is just PVC and some primer and glue. Duct tape, of course.
This
Yeah,
great
clearly.
plastic box here to hold all of our wire.
Yeah, and this lovely plastic box to keep everything watertight. In these pictures, you can see it that was when we first threw in the water to find out if it actually floated.
And
If we did our math right, it did. Unfortunately, we did find out there was a hole in our boat.
It still has water in it right
Yes,
now.
it still has water. We tried fixing that. We used caulk to seal it, but we don't know if it actually worked. But it still floats. This right here is not in those pictures because we added it later. It is just our magnetic sensor, which you will learn about in a bit. And then our final piece is that the one thing we did really different from everyone else is the lid. We put a switch on top of the lid so we can turn it on and off without needing to reach into electronics while in the water to get it back to us without doing anything too horrible. Okay. So, wiring. That was basically my job because I've always enjoyed wiring. With wiring, first we had to do the external switch. That was probably one of the hardest things because first we had to figure out how it worked because it's much different than, probably more complicated than anything else in this. Because it's 3 different wires that we have to connect, and then, no, 6 wires that we have to connect to make sure it goes to each of the motor controllers correctly and to the battery without making sure anything gets crossed or overly overheated so it doesn't fry itself. Then we had to attach the motors, which are right here. That was very basic except for the connectors. The connectors that we had are a really pain to put together. Then soldering the sensor. I love soldering. It's really simple, but this little tiny itty bitty thing right here on top that's as level as we could get it is the sensor. We had to do all this work to make sure the sensor was here on level. Soldering was really simple. It was just a couple of dots on the top and the bottom. And then the pin number does make a difference. So we found out while programming that something was wrong. One of our motors worked in reverse. There was issues we couldn't figure out. turned out our Arduino board, 2 of the pins didn't work, and that just happened to be the 2 pins we were using. So that was basically the PWM issue. Next slide.
So when we first learned about programming, we learned with some smaller robots instead of just going on using the motor. We learned that we learned 2 ways to write onto the Arduino board. One way is digital write, which is what most of us use for our robots. Because it's simpler, there's just an on and off, like binary. And the other way is analog write. This is possibly a little bit better for our boat because you can put in a higher or lower number depending on what degree of electricity you want to send to your board. So originally when we started to write the test program for our boat, we started writing it in digital write because that's what we were used to, but we found out that doesn't work. So you need to look into these things before you start to make your project.
So we did some more troubleshooting here. Basically, when we were doing the programming, one of our motors was going really slow compared to the other one. And that's where we did some of the troubleshooting to figure out what was wrong with it by changing all its power when it kept doing the same exact thing no matter what we did to the power. So that meant something was either wrong with the board or the motor control.
So we did this all while our program was still really simple before jumping in with the sensors.
So when we were doing the sensor, there were 2 different ones. There's the GPS and the magnetic sensor, compass basically. I think we didn't end up using the GPS sensor because you had to use the magnetic one first, and we could barely get that to work in the time that we had. So, but basically the magnetic sensor, it detects magnetic north. It detects the amount of magnetic force, and then figures out magnetic north, and then based on that, it can navigate. So, yeah, we originally were going to use the GPS, but we just didn't. We had to accomplish the magnetic sensor part first, and we didn't have time. One of the things before we were doing dead reckoning, and the code was very simple, and it was pretty easy. But as we got into the sensor, it was lots and lots of strings of stuff that I had a lot of took a lot of time to learn what I was doing. So, and it took even more time to. It says up there clean code so that you can understand it and formatting it right and stuff. So that was a big challenge, and it was pretty fun too. So, yeah, and comments are very important, especially the next day. So.
Then trial and error. One of our motors went backwards. First it was, we thought the motor was bad, then we tested the motor was fine. Then we went through our motor controller. The motor controller we thought was bad, so we changed that out. And we did all this like within like 20 minutes, and it still wasn't working. So then it just came down. We just swapped something in the program, what the inputs and outputs were, and we switched the pins in our Arduino, and it was gone. So therefore it was the 2 pins that were bad on the Arduino.
We had water in our pipes, and to fix the water, we added more duct tape so that it would close the hole that was here. And the motor was going in reverse instead of going in the right way.
Yeah, we fixed that with we replaced the motor. Yes.
It took a long time to find that it was the motor controller, though, so even more troubleshooting was really tedious.
Okay, so I think we're all gonna go.
Yep.
All right, so we're all gonna go, but I guess I'm first. For what I learned a lot about coding, programming, because I came to this and I had little knowledge of it, and then I was like, whoa, what is this? So I had to learn all this stuff. So, and a little bit about physics, the buoyancy, that was pretty interesting. And wiring's his department, so.
I'm sorry. Well, coming coming into this program, I thought, I don't really have that much experience with engineering, so when they told us we have to make a whole boat with wiring and things, I was like, I think I'm in the wrong classroom. But it turned out to be okay. It was very helpful. And I only came here because I'm going into computer science. I did a little bit of coding myself before, so in this program, I kind of reaffirmed to myself that I am interested in coding, but I don't know if I would want to do anything related to mechanical or electrical engineering. So I would recommend this program because you really get to see what particular things about STEM that you like and dislike.
Coming into this, I didn't really know much, so I learned coding, which is one of the things that I need for my major, which is computer science.
And then me, I came into this program, I had some basic understanding of code, and I thought I had it. Then I learned that I actually have no idea. Then with physics, I haven't taken physics yet, and while we were doing this, I learned about the buoyancy, and that was super interesting. Then wiring, I've been doing robotics for years. I've always enjoyed wiring. Then as we were doing this, I learned a few different ways we can wire, like soldering. I figured out ways to make sure we didn't have to use 3 wires for the motors, and I cut it down to 1 using some help from our junior mentors. And that was really fun.
Well, working in a team is pretty hard, but it worked out.
Yeah, any questions? Yeah,
Yes, give me-
orange shirt.
Oh, her name is Kim.
So, for each of you, what was your favorite part about the camp? Like, tours included and building included?
Well, mine by far was doing the wiring and seeing the railgun here. That was awesome.
So my favorite part was when I actually started writing the code and it was working, seeing my robot do stuff that I coded for it was pretty cool. So
My favorite thing was all the tours that we did because it helped for what I might want to do for a job.
If I could be very honest, my favorite part was in my friend group at my old school, none of them were very interested in science. I've always been surrounded by people who are interested in humanities. So I kind of had a poor opinion about engineers and such. They're like know-it-alls or something. So it was good to come here and know that, no, we're actually all just really hee-hee and awkward and chill. We're just people, too. So it was good to get to know all of you. That was my favorite part. Any questions?
No question.
Mr. Boyner.
If 1 month from now, your team is asked to do this all over again, build us a boat, go around the buoy and so forth, would you change your design? How might you change that? What improvements would you make?
Well, make sure there's no holes in it for one.
Personally, I think the basic design is all right, but I noticed that some other teams' boats went a lot faster than ours, so I'm not sure if it was because of the design or the motor, but I would try to make it maybe. I would just try to get better parts, and we'd work on the programming more. I think with time we would have been able to get it around the buoy. I'm very confident in that. Was there any other questions?